If you're looking for a deep dive into the history of consumer and enterprise SSDs, a checkered past that stretches back about 9 years now, all the way right through to today's NVMe and tomorrow's NVDIMMs, with 3D XPoint, which Intel calls Optane, and Micron calls Quantex. Well, then you are in the right place. Here we go, recorded April 6th, 2017. This is Paul Breran from TinkerTry.com. My first time I've ever met Allyn Malventano in person.
Hi.
Hey, Allyn. We met an hour or two ago.
Yep.
And we both owned, about 9 years ago, the first Intel X25M. So if someone here is listening to this and actually remembers that SSD, want to remind us what was special about it, Allyn? You finally kind of remember it?
Well, yeah, because I was not a reviewer when I bought that SSD. Actually, this is funny because this totally overlaps with what you do. You know, Intel only spec'd that drive to handle like a typical OS install and like maybe a bunch of other like application installs and like bulk media, and anything after that would have just been like pictures and videos saved to that drive. I bought one and promptly installed the OS and then installed 2 VMs.
Interesting.
And apparently that was enough random writes to the drive to overload the way that Intel was tracking how they were doing their translation layer to their flash, in other words, to handle wear leveling and everything. And it actually grew the database to be too big and caused the write speeds of the drive to drop to like less than 20 meg per second. It was supposed to be like 80. So yeah, VMs actually caused the story that was the big deal that caused Intel to do firmware updates to that drive to fix a problem. That's pretty funny.
All right. Well, that's a painful story. I actually bricked one of mine and sent it in for root cause for Intel, knowing I was a pioneer and spending, what was it, close to $1,000, right?
So when I bought it, it had been out for a little bit, like a few weeks or something, and it came down to like $650 or $700 or something. That was how much I paid. It's crazy cost per gig back then.
So, Allyn, just getting you going already, this is easy. I'm barely talking, but I didn't even finish really the introduction. I'm sitting in PC Perspectives Studio, so thank you for letting me record this here.
Yeah.
But, well, trim is the next topic, right? So that X25M didn't have it, right?
No trim.
And we both would abuse these drives and own them for months.
I mean, a lot of people didn't even really have a concept of what the heck trim was at the time. Like, it wasn't even a term that people were throwing around.
Yep.
Right? So, you know, it just wasn't even a thing. And then people started to talk about it because you had other SSDs come out that could support it, like some ND-Lynx controlled SSDs or some OCZ, other ones were coming out at the time, right? Intel kind of took a long time to even support trim in any way. And what's funny is that there wasn't OS level support yet, but you had like, again, OCZ, like people were toying with all sorts of different things. Like drives would do some kind of garbage collection in the background when the drive was idle, and they would try to like read the file system that was on the drive. Like it would only work for NTFS partitions and whatever, and they would actually make the drive firmware peek at the data to try to figure out what sectors were allocated on the drive and sort of trim themselves, right? So that went on for a while, an experimental stage. Yep. I don't know if any production drive actually shipped that way, but I definitely tested a few.
Cool.
And then it got to the point where, you know, there would be some command line thing that you would run under Windows that would sort of force a trim. It would go and check and see what free space there was on the drive, free physical space, or at least free LBAs, and it would like go through and try to like manually issue trim commands to the SSD. And there was all these tricks to this because like if you had specific storage driver, it wouldn't work because it couldn't talk to the drive directly, or
Intel RST or RAID controllers.
Any of that stuff. Yep. None of that would work right. And then you know, it wasn't until now I'm trying to go back and remember like which version of Windows was it that they actually had native trim? Because this was a while ago.
Remember Secure Erase too? Like if you and I, you know,
it was the same deal for Secure Erase. Yeah, you usually had to do like a command line, not command line, but boot into like, you know, an equivalent of DOS or FreeDOS or something to do Secure Erases back then.
And that X25M, when I bricked mine, it's like, oh, what data's on there? Because to warranty or do an RMA swap meant trusting them and just sending it in.
Yeah.
So there's all those complications in early days. That's 9 years ago, though, right?
Yeah.
Let's go to like about 6 years ago. This is when I, almost 6 years ago, I started blogging about LSI RAID controllers. Why an LSI RAID controller? Well, the OEM for Dell and HP and IBM, all the companies making RAID controllers, $600-700, a decent RAID controller called 9265 8i. has some cache on it.
I think I have one on the shelf over there.
Yep, an option with a key, a hardware key to enable some read-write cache if you bought enterprise-style SSDs. This is 6 years ago.
Yep.
What was unique about it was OS agnostic, meaning it might actually work with VMware, which is notably finicky about home lab kind of stuff and with stuff that's not on their VMware compatibility list. So it was promising to me. Did it fill that promise? Well, when I used consumer SSDs, I managed to corrupt a RAID array. So no, we found these things out the hard way by trial and error.
SSD firmwares were not the most reliable, especially for drives running in a RAID back then.
Correct, and using it as a caching layer where we get abused, and it was consumer, not meant for it. It was a sure recipe for corruption.
Yeah, you were almost asking for it to just brick something at some point. Yeah.
Yep. So I don't blame any of those companies, only myself. But you're trying to push the envelope of what's affordable. Yeah. And not buy a high-end Intel or Samsung at the time, which were pretty pricey 5-6 years ago.
That was the original reason for RAID in the first place, right? It was supposed to be inexpensive disks, supposedly.
So to my surprise, a lot of people also bought that RAID controller. And the reason for VMware that's been explained to me, and you can correct me here, a lot of it had to do with, let's see, queue depth and just a decent RAID card. Whether it was pass-through or not, anything blew the doors off of SATA for speed for VMware, particularly 5-6 years ago.
Sure.
It was horrible if you ran like 2 VMs in there, just like if you ran VMware Workstation.
Are you talking if there were like spinning disks behind the RAID controller even?
Even 2 SSDs.
I mean, it did apply.
But yeah, let's go to spinning disk. The speed would not be, let me back it off a little bit. Let's take a spinning disk 5-6 years ago. Most likely it would be. You formatted VMFS under VMware, and you would hope to get like 70 or 80% of what you would natively if you had Windows running and you ran natively and did like ATDO add-on, this bench, right?
But if you didn't have queuing.
Exactly. And when you tried to boot 2 VMs at once, it would start thrashing. Or even if you went to SSDs on SATA, your speed was pretty horrible.
It would still,
So you'd buy a RAID controller. You'd fix the problem with $600 and you'd pass it through JBOD mode. Or make a RAID 5, and then you're good.
Well, without queuing, you would notice, especially for like 2 VMs in parallel off of an SSD RAID, if there was no queuing going on, you'd basically, it would literally cut the IOs in half, like your IOPS throughput. You get per like VM, right? It would just subdivide it evenly.
And that's where you felt this performance would tank.
And there would be no ramp up. There was actually one page in my X25M story. Even though Ryan had already published the review like 5 or 6 months prior, when I wrote the story on that SSD's performance, I dedicated a page specifically talking about why you should turn on AHCI mode in the BIOS, because at the time most of the defaults for systems in their BIOS was compatibility mode, IDE compatible mode, which was no queuing. So there was
even worse for VMware virtualization.
Exactly. So and that was like straight to that was not even a RAID controller issue. That was like the only thing in the system was the one SSD, and most people that were buying those SSDs at that time didn't even know any better.
Good segue to...
like they were running not queued, where they could have got so much better performance out of it if they were having, even for doing normal stuff, right? Even for not even VM specific or multiple VMs or anything crazy like that. Yeah, so that's totally a big deal. And then also, there's a bunch of RAID controllers, especially at that time when SSDs were starting to come out, that even though you saw a benefit with hard disks by doing queuing, there were an awful lot of RAID controllers that even if they supported queuing between the RAID controller and the OS, they didn't do any kind of queuing to the drives that were connected, or vice versa. Some of them would go the other way. Like there were very few RAID cards that would actually go support queuing all the way from point A to point B, like OS all the way through the RAID controller, all the way to the SSDs, right? That's actually the reason that I got kind of hooked on Eureka RAID cards, because they were the first. They were the first one I could find back then. Granted, they're all much better now, but back then they were like the first guys to do it.
You had IP management in that too, RJ45 jack in there. Or?
Yeah,
very nice, right? Where versus Mega RAID for LSI, which was difficult to run in a VM to say the least.
Oh yeah,
you had to do these convoluted hoops to get Mega RAID to run in a GUI. So you had to roll up your sleeves with a CLI, run in a VM. That was tricky, and that was a very popular article. And I realized, tens of thousands of people buy these RAID adapters. I had no idea. Like people were that into home labs that they spend $400 to $700 on a RAID adapter to get decent performance. So that's 2011. Part of what goes with that story of starting blogging about it, realizing there's other people doing this, was motherboard choice. So you may recall, 2 terabytes was a nasty boundary for VMs. He's
Remember that?
Yep.
Asus at one point had like this custom like special BIOS option they tried to roll out to like do BIOS level support for greater than 2 terabyte, like to boot from it, because it was a thing, like to try to even make that work, right?
Looking something up here,
it was. I remember the name of it, but it was some special feature that like we toyed around with it for like a week or two or something at one point, and it kind of died on the vine because, you know, eventually just everybody realized, well, I kind of need to move past Windows XP anyway, and just, you know, I'm just going to have to upgrade my OS. Sorry, even though at the time I was still running like XP 64-bit personally, and I just went for the longest time. Actually, even today, my boot drive is never greater than 2 terabytes anyway. Like, I'm never booting from, it's always solid state something or another. Even if it's solid state RAID, it's still not greater than 2 terabytes. Even now. So I technically could still be getting away with running XP64, but like I gave up on the printer driver battle and everything else. Like, you know.
So back in 2011, you were just getting PCIe. 3.0 was coming out.
Was coming out, yep.
UEFI BIOSes are still pretty early. You generally still went with legacy mode on your systems.
Yep.
And for that story of 2 terabytes, trying to break that boundary for myself and my VMs, as I met you, we were talking about some of the personal reasons you get into storage. You start breaking past 2 terabytes, whether it's a video collection or photo album, whatever it is, you get past 2 terabytes and you want it all on one drive letter, you're now looking at things like Windows Home Server to take a bunch of drives together, or NAS, free NAS, other options to make roll your own NAS, or Drobo Synology if you can afford it. Back in 2011, the other thing was with a motherboard, what if I can find one where I can pass through VTD? Sounds like a disease. You remember VTD, that acronym?
Yeah, but
the Intel feature.
That support back then?
Well, I found...
Did it even exist back then?
Starting. So I went and bought Gigabyte, ASRock or ASRock, Asus, and MSI. All 4 of them in a Z68 chipset, Sandy Bridge, early days. 2 of them went back because I couldn't get them working with VTD. You couldn't find it published in any of their specs or manuals.
Of course not.
And 2 worked out. So it turns out ASRock, the one I kept, and MSI Z68 motherboards could do direct path. Why did I care? You take a USB 3 controller, PCI card for $60, a decent one that had 4 discrete chips, 1 for each USB 3 port. So it had decent performance. They all had their own discrete chip.
And a power connector.
And you could pass through individually each port to a VM. So now you had an external cheap $180 RAID 4 drives in one external USB 3 bundle, pass it through to a VM, and boom, you had yourself a 4 terabyte or 6 terabyte size data store in your VM.
That's pretty cool.
Kind of passing through. So I share that because it's gotten better, right? It's gotten a lot easier now. So
Thank goodness.
5 years ago, what a mess, what hoops I had to jump through.
There was actually one point back then, not specific to VTD or anything like that, but like I was just experimenting when I was going through all of the other RAID cards. I had actually bought, similar to what you did with motherboards there, like before I settled on Eureka, I had purchased Promise, Highpoint, LSI. Like I'd gone through all of them.
Wow. Yeah.
And put them back on eBay, and we got the next one. Put it back on eBay, got the next one. And like I just didn't like, you know, at one point I think it was like I had a Promise card that would only write at like 20 megabytes per second. I had like a 6-drive RAID connected to it with like decent drives at the time, like 400 gig drives or something, 7200 RPM Western Digital Blacks or something like that.
What was the price roughly of that card?
Oh, the card was like $500 or $600, and it was only writing. It was only a RAID 5. It was only doing XOR for parity, and it was writing at 20 meg per second, like hard limit. Like the card just would not go faster than I was like, what on earth is going on here? This is ridiculous, you know. So went through all those cards, and in the process of that, when I got to Eureka, Eureka worked fine, but it gave you the option. Eureka cards give you the option when you make the array, like you can actually make it 64-bit addressing if you want to support greater than 2 terabytes in the array, right, for the OS. But the OS needs to support greater than 2 terabyte partitions, obviously, or you know, a greater than 2 terabyte device, right? But another option was 4K, like you could do 4K sectors, just like at the array level, right? And just for grins, I was like, well, let me try this. And I ended up finding a bug in like, I think it was XP64 at the time. I made I had like, whatever it worked out to like 2.5 terabytes worth of storage or something like that.
You use 64-bit Vista too, like me? It's crazy.
No, I skipped Vista. To
get past the 3.2 gig of memory, you needed to go to 64-bit OS way back a decade ago.
Yeah.
That was me, because I needed to show off VMs and run past 8 gig of RAM.
Yeah, well, XP64 would do it too. You could do that. It would rearrange it, and you can get away with that. But like,
it was really painful.
I found this weird bug with how Microsoft handled it, where it showed up as like a greater than 2 terabyte volume. Everything worked peachy. Everything looked fine. And it formatted everything, and this was 4K sectors, not 512 byte sectors, right? And you figure like this is abnormal for Windows. It's not used to dealing with 4K addressed, devices, especially back then. It's even tricky nowadays. If you get hard drives that are advanced format that internally do 4K sectors, they still present as 512 byte sectors, or at least that's an option. There's always a SKU of a product that's the old style sector mapping, right? Even if it's emulating it, right? They always call it 512E for like it'll be part of like a drive model or something of
even
like,
all the way up to HGST 10 terabyte Helium drives?
Yeah, yeah. There'll be the enterprise version of that drive. There will be a separate SKU that's a 512E, logically handled sector.
Not
mapping,
the ones you
right?
liberate from their plasticky external USB 3 enclosure.
No. Well, those
just point that out, right? Because that's how you get the price down, but they're consumer ones in there.
Yeah, sure.
Yep.
So I'm like, all right, well, cool. This thing works. It made a partition, whatever, and I'm like, all right, well, let me start copying. I start copying over everything that was on my other array at the time, right? And I just start filling this thing. Hadn't deleted anything yet, thank goodness, because as soon as it literally crossed past the 2 terabyte, like 248 gigabytes worth of like putting a file on the volume, Windows lapped it back to the beginning and overwrote the file table.
I left you with an interesting file system.
So it literally just, as in a non-existent one. It just like, it was just like filling. It's like, all right, well, that's cool. I've got like another few hundred gig left here. It's just about to cross the 2 terabyte thing. Walked away for a few minutes, came back. There was just no file system on the drive anymore. It was gone.
Nice.
Like instantly, with no errors, nothing. It was just, there's just no file table anymore.
What year are we in now in your story?
I mean, this would have been, this would have been like probably around, we're talking around the X25M time, so we're talking around like 2009-ish.
All right.
Right?
That's a rough story.
I just thought it was hilarious. That, like, something that you could not have possibly learned unless you have had the volume. It worked perfectly until you filled it past 2 terabytes. That's what amazes me, is that you could have been oblivious and put all of your important stuff on there. And then just that one more piece of tinsel on the Christmas tree, and then just poof.
Seeing you smile, it's like a painful smile because
it's a painful smile.
It's a joy of discovery though in sharing it, right?
Oh,
when that happened to you, you couldn't wait to write it up and tell people about it.
But the thing was, right? I wasn't writing anything.
Oh, okay, that's
like so. I wasn't a journalist yet. That was just experience.
So what got you going? X25M. You said that's a little bit hooked to that story of becoming a journalist.
It was X25M, and like, who the heck do I tell about this? It's not like Intel tech support's going to deal with this guy that's. Just drives going a quarter of
So that's where it
speed.
started. Your spark there was 9 years ago at X25M.
Yeah, and that was Ryan dragged me into that spark actually, because it was me emailing the people that wrote the reviews that I read, asking, "Hey, I'm seeing this weird problem. Can you reproduce this?" Ryan happened to be the only guy that bothered to take the time to respond. And then it led to back and forth. I'll write this thing, send it to your person at Intel. Maybe they can figure something out. I wrote him like a short, synopsis of what I saw and what I thought was going on, whatever. In those back and forths, apparently he was impressed enough with my technical writing of whatever I was doing. He's like, hey, I could use a storage header since I'm just doing all these CPU and storage reviews myself right now. So it just led to that. And then here's your first story, Al. Write up this Intel thing. So basically, like, no pressure. Go up against, like, Intel for your first article you ever publish on the internet. Okay. So,
intimidating, sure.
It all worked out.
It sure did. No, I really appreciate you sharing that backstory. I did not know about that. And let's move forward a little bit. So 2011 goes into 2015, became kind of the dark ages for home virtualization labs because you're stuck at 32 gig of RAM. So if you're looking at around $2,000, you waited for Sandy Bridge, you got Ivy Bridge, nothing really happened. You had some motherboards that might have had 8 DIMM slots, but now you're up to 150, 160 watts probably, rather than like 120 or 100 to 120 at idle. It wasn't very exciting to move to a very niche few brands of motherboards that came out with 8 DIMM slots, because the amount of money you'd spend to get past 32 gig to only go to 64. So I just patiently waited, held my money, and then finally ZND announced March of 2015, right around when I was in Tucson, Arizona, working on an IBM Redbook, actually, listening to your podcast, commuting each day in the desert of Tucson, seeing the solar panels all around me, and just kind of enjoying the half-hour commute. One of those drives where you're hoping the drive takes less time because you want to finish the podcast. It was cool. And you were talking about NVMe at the time and booting from it and some of the hassles. And I remember thinking, it seems like bleeding edge. Maybe a little too early to try this at home and kind of expensive, but I was hooked. I'm like, I still got to get my hands on it. I've been waiting to dump SATA and the protocol overhead and all that. We'll talk about a little bit, but it sounded interesting to me to finally get through SATA bottlenecks and then flash forward to today. And we'll talk about, let's get through NAND bottlenecks as well. But that's a foreshadowing a little bit. So back to 2015, ZND arrives. It's got the M.2 slot in the motherboard. Didn't really ship in volume until the second half of that year. But I was already blogging about it for months, knowing 128 gig of RAM, 2 10 gig interfaces, 2 1 gig. Like, oh, this is it.
That's a good system.
And it's more affordable. Yep.
Yeah.
And it was still around $2,000. And then a year goes by and they come out with, let's get under 1,000 and give you all the way down to only 4 cores, more like mobile, but it's still a Xeon.
Yep.
All the way up to 12 cores and all the way up to even 16 cores. So your watts go up, but at idle, they're almost all around the same, 24 to 30 watts, which is really modest.
Yeah.
So now that home lab proliferated where you could have many different form factors all the way down to 1U. So why do I share all that? Because the M.2 was like the secret sauce. That was the piece that people discovered you don't really need to buy a RAID adapter anymore. Why not invest that $600 to $800 you used to spend, just stick a Samsung 950 Pro, the darling of the home lab world, where you could boot 2 VMs at once off on it, and it didn't tank for performance.
Yep.
So if you could take the listener, whoever's listening to this, through, why is that, Allyn? Explain.
Oh, there's a few reasons. Like, first of all, well, you have queuing even on SATA, granted. Right.
And it's PCIe 3 by 4 lanes, I should mention. So the motherboard meets the minimum spec you want for full speed Samsung 950 Pro.
Right. That's the thing. So you end up with more bulk throughput on the device. Okay. But another thing that we're actually kind of moving away from on like typical client reviews, which is where like the thing that we're kind of spearheading now is that, look, you shouldn't be looking at queue depth like a 128 or whatever the NVMe SSDs are rated at, like the crazy high queue depth performance. For an individual client, just playing games on their PC or whatnot, right?
Now compare that to SATA, by the way.
Yeah, well, for either, still applies. Okay. Your queue runs very low, right? Sure. However, if you're running a VM server like you are, that's where NVMe really shines, because not only does it have queue depth that can exceed 32, but it has as many queues as you have cores in the system, right? And its queue depth max per core, if I remember this right, is 65,000. So, but not that you're ever going to get that high on a queue, but like they clearly designed that with like, okay, we don't want any limits to be in the way, so let's just make this in a way where there's just no conceivable limits as far as queuing or anything like that goes, right? So in a VM environment, it's actually really, really good as far as like, you know, if you look at any given like IOPS versus queue depth chart for any, you know, NVMe part, it's definitely ramps up all the way up to like 128 typically, all the way up to Q128. So you're going to see increased performance as you scale up and start running a bunch more VMs in parallel. So, you know, definitely lets you shine there. Now the things on the individual client side, again, flipping back to people that are not running, you know, crazy VM machines in their basement or whatever and serving like, you know, 20 different people in the house at the same time.
Yep. No, I'm just talking about people like me, an IT pro is trying to run 2 or 3 hefty VMs that are doing some real workload.
Yeah. But you still see a benefit there.
Not
like
benchmarking, just running multiple VMs that are actually doing stuff at the same time.
Yeah, exactly. So those will climb, you know, you can climb 8, queue depth 8, queue depth 16, queue depth 32 even in those cases. And like a, you know, good NVMe part is going to see more and more performance when you do that.
Bring up an article too.
The thing we've been kind of shifting focus on lately for client testing, for individual client using an NVMe SSD, is since you're just an individual person just doing typical stuff on a computer, they're going to be at much lower queue depths. So we start focusing more in our testing on what is the lower queue depth performance of that device. In other words, how quick can it turn around individual IOs being requested, not how high can it ramp when you're, you know, throwing a whole bunch at it, in other words, right?
Okay.
And we come to find that in many cases, SATA actually looks very similar to a lot of the NVMe parts. Like in our result charts, we actually have some NVMe SSDs, recent ones that we've tested, that actually fall lower in the chart than some of the better SATA parts. Because again, we're only focusing primarily on the lower queue depths. So while the NVMe part can scale up and ramp up to over 200,000 IOPS plus, you know, depending on the part, SATA parts can only really get, you know, around 100,000 IOPS across the bus, because the bus bandwidth is the limit, really.
Okay.
You'll still see SATA parts turn in lower latencies if it's a better SATA device and with a faster controller compared to an NVMe part with a slower controller, for example.
And again, for the average user, single use, they're only using a few threads of execution. They have a mobile processor with only 4 cores max, but maybe for antivirus or something in the background, but they're really just surfing or checking email.
Yeah, exactly.
They just want to get the price point of the SSD lower. We're not bashing those products, right? It makes sense when it's just a single consumer.
Yeah.
Super cost conscious.
Yeah. So there's still, at the beginning of it, it was really everybody was locked in on, and again, this actually perfectly suited what you're covering typically for VM stuff, but unfortunately, most of the other reviewers ended up locking in on, oh my God, look at if I do QDepth 128, look at how high the IOPS is. Okay. Nobody was actually, getting there, right? Nobody that's checking their email or playing Doom or whatever is getting anywhere near QDepth 128. They're running like no higher than 4, right? Okay. Actually, what's really funny, even along those lines, like even like what we used to call a fire-breathing SSD, like a Intel SSD 750, which was basically their enterprise part, kind of refirmwared to become a client SSD.
And this is what you're talking about, I think, in the early 2015. Am I got the date right?
Yeah, it was around then. Yeah, it was like mid to early 2015.
I got my hands on one of those.
That's when that part came out, and that part, my goodness, it looked amazing in all the tests. But the thing was, most people weren't focusing on like random reads at a low Q depth. And that part actually performs very poorly now, like by today's standards, as even like an M.2 SSD that draws
the Samsung 950 that came
out. Like even when the 950, not even the 960, right?
950 Pro.
Yeah, when the 950 Pro came out, even it was running circles around an SSD 750 from Intel, even though the 750 was basically based on an enterprise part, especially at low Q depths and like random reads, which is the majority of what client use is. Like you're not normally doing random writes to your SSD, not a lot at least. And the random reads are the kind of things like you're launching applications, you're booting the OS, like that's all a heavy, like random read type of workload, right? The like M.2 part from Samsung that only drew like 5 or 6 watts was running circles around the 18 watt draw 750 series part. Based on an enterprise part.
In a compact Xeon D server, which is like a cubic foot, less than 12 inches on any side, right? So it's a small amount of volume and a fairly low speed fan. You didn't have a lot of airflow over the M.2, so people make a lot of hoopla about, thermal throttling. My response was always, okay, but it's still way faster than any SATA drive. And it'll thermal throttle, okay, it'll lose 20-30% of speed if I don't crank the chassis fan to high. I can crank it to high and get around it. It won't slow down at all on the particular Supermicro box.
You're talking like a 950 Pro? Is that what you're talking about?
950 Pro, yep. Yeah. The way the airflow was in that particular Supermicro box that's on the VMware compatibility list, which is rare for home labs, but it's actually on the list. If you cranked IPMI setting to FETmax airflow, you could bang away at the SSD, the 950 Pro, for a long time, and it would not thermal throttle. But if you wanted a reasonable volume, it would. But again, 30% drop, only if you bang it away for more than like 30 seconds. Almost nothing bangs it away that long. Well, cloning a copy of Windows 10 would be 20 seconds.
Exactly.
And it's done.
And here's
That's
the
point, right?
Even like any kind of continuous random workload, basically nothing that any home user would do could possibly get it to thermal throttle on its own. In the VMware side, you'd probably have to spin up 3 or 4 VMs and be doing like active Windows installations to them at the same time. I think that might be how much of like an IOPS sustained you'd have to do and to actually get it to start running into the temperature where it's going to throttle. And that's assuming there is literally no airflow across the thing.
There you go. Open air tests I've done too at user groups and stuff. I just take the lid off and say, hey, it still clones really fast.
Yeah. I mean, I was doing that testing. Like I literally had to put like a couple of pieces of cardboard around the thing to kind of box it in.
Sure, duct it a little bit.
So that there was, just to make sure there was no air even moving across the thing. And even then I had to hit it with a sustained, we're talking like the kind of test that I run workloads, which is basically saturate the drive with random, which like a normal system never ever sees. Like QDepth 128 random writes. No, like that's never, nobody's ever doing that ever.
You're torturing things so other people don't have to. And you're gaining your trust in the product in the same, you bought a FLIR thermal camera like I did. You want to abuse it before you trust it with your data, right?
Yeah, so there was I think the thermal throttling thing was kind of overhyped at the time. And even now, if you're buying a 960, now they have that copper infused label on both sides of the drive, and it acts as a heat spreader, which is interesting in its own right. But I mean, it does the job, and it's way harder to throttle that model. And even when it does throttle, it doesn't throttle nearly as much. It only drops down by like 10 or 20% or something of its throughput.
So great segue to today's stuff.
Yeah.
So ZND comes out, you can go to 120 gig of RAM, M.2 comes out, now you got a second generation 960. It's going to run cooler. It's got this copper thing that you blogged about real early. I saw your pictures and all that.
That actually also helps something else that I keep trying to correct people on this. Nobody seems to understand it. There's all these things coming out now, like heat sinks, heatsink housings to mount an M.2 SSD into and then put it into like a PCI slot or something like
Angel
that.
Bird.
Angel Bird makes one. Yep. You know, and
Amfeltech and others have a little ceramic square thing you stick on the controller part, the hot part.
Now that is I could get behind, or
and I got 3 or 4 brands of those at home.
I can get behind that, or I can get behind a heat spreader, which would spread the heat at least across the rest of the M.2 SSD and, you know, warm up the flash. Now, why would you want to warm up the flash? Nobody seems to understand this. If you run flash colder, so say you use an SSD, you have your 950 Pro in that system at your house, right? Say you had a huge heatsink on it that basically ran the flash and the controller, kept everything basically ambient all the time, okay? Now, spin yourself off to a parallel universe where you didn't put a heatsink on that guy, okay? And you did the same exact work, IOs, same amount of writing to both of those hypothetical systems, right? And then you shut off both of those systems and you let them sit for like a year, which is actually the rating for client. It's supposed to last 52 weeks and still retain all of your information. And that's at the end of the life of the flash. Okay? All right?
That's really good stuff you're talking about that nobody talks about. Right?
I know, nobody talks about that.
For your data,
but
how long does it last?
Here's the kicker. The system that you had the heatsink on that ran at ambient temperature the whole time would have half of the endurance compared to the system that you ran at normal operating temperature of the flash. Because flash memory, if you write to it while it's colder, has to do more work to accomplish the writes. It's harder for electrons to tunnel through an insulator when the insulator is colder. You actually do more damage to the channel by doing the writes while it's colder. Okay? Now, when you store it and you're not using the flash and you're not writing to it, the colder the better, because now the electrons are less likely to leak out. Okay?
Yep.
So the way that they rate a consumer, like your 950 Pro, the way that the JEDEC standard for rating that guy was based on a certain operating temperature and a certain storage temperature. So the storage temperature is like 25C or something like that, and the operating temperature is like, I forget what the number is, it's like 35 or 40 or something like that, right? So the idea is that while you're actively writing to it, you want the flash to be warmer. And then if it's cold storage, you literally want it to be cold, right? So that's why your best bet is not a huge heatsink that's going to cool everything down. You want to, if anything, you want to use a heat spreader so you can take the heat from the controller. The controller is the thing that's making the majority of the heat anyway. You want to take that and shift it over to the flash to warm up the flash. So that way, in cases where you're really hammering away at the SSD and doing a bunch of writes, the controller is going to warm up. Well, you want to help the flash warm up.
Spread it out.
And that would actually increase the life of your SSD. Not to say that SSD life is really that much of a concern for any normal person.
Yeah.
Because it really is very hard to burn out one of these things. I mean, there's more than enough in endurance and retention for anything like that. But yeah, it's just...
No, thank you for getting into the weeds there about the temperatures too.
It just cracks me up, the whole like heatsink thing, like this huge thing where all these companies try to come out with these M.2 SSD coolers to stop your throttling. I get it. It's a marketing thing. People see that throttling is an issue. They come up with a solution. Like, we can make a heatsink. That's easy. But it actually, yes, the SSD will thermal throttle less. However, you will wear the flash faster than it was rated for.
So that leads me to your incredible graphs and mastery of Excel and all that for real data, right? To getting past the marketing stuff and reading your articles as references. That's why hundreds of my articles point to PC perspective, right?
Yeah.
Those are good things. It's not you're bashing these companies, you're helping them be better by being truthful about their stuff.
Yeah.
Including where they trip over. So let's talk about tripping over. Samsung 960 launch. There were some problems that surfaced very quickly on my site where people right on the front page, I prominently have people's comments. Yeah. I rarely...
Do you run into like the drive was dropping out or something like that?
Disappearing, exactly. And you and I talked to each other a little bit.
I wasn't seeing that on, like, nobody was telling me about that because the typical people that are writing to me are not, they're just gamers, they're just building their PC, they're not running like excessive VM kind of infrastructure.
Most virtualization people, not so much either. They're teaching themselves a class or getting certified, and then it might sit off for a month or two. So I was a little surprised to see it. And you didn't confirm, like, oh, this is a lot of people. So maybe it's only 2% or 2%, I don't know. But a lot of people were buying the 960 Pro, ordered it months before Christmas. It started shipping December 23rd. That's when I got mine.
Yep.
You had yours months earlier as a review edition, but we shipped to the masses in that date. The 960 Evo did better they got a firmware out there, and it no longer disappeared. Let me explain what I mean by disappear. Your data doesn't disappear.
Yeah,
the drive would disappear.
The drive just disappeared, yeah.
And most BIOSes won't enumerate M.2, so you won't really see in the BIOS, but you'll go Windows or VMware or NAS with some sort of Linux, it would just disappear. It wasn't visible to those OSs. The workaround that somebody commented on my site said, hey, I found a workaround, just unplug the power cord, de-energizing your motherboard for a little bit. Now plug it back in, and guess what? Your data's fine. Your M.2 just comes back to life.
That's so weird.
So here's where it got weirder. Is this going to be a BIOS fix from the likes of Supermicro and Gigabyte and other brands that were getting reported on my site? I'm mostly talking about M.2 and a particular ZND motherboard.
Yeah.
The reports were coming in from all kinds of motherboards quickly. Here's what happened. A month went by, you couldn't get your return anymore from Samsung, so you're now committed to their product.
Sure.
If you didn't report the flaw and that it was disappearing on you randomly, particularly after soft reboots, you might disappear. So you'd have to shut down gracefully, unplug your power cord, boot up to get around it. So it's a little painful if you did a normal soft reboot without pulling out power.
Mm-hmm.
All right. So the 960 Evo had a good story ending. About 60 or 90 days in, they did update a firmware. You had to use Magician. They didn't have the bootable ISO yet. So for VMware, you want a bootable ISO because you don't want to throw Windows in there just to put Magician and download from the internet. A little cumbersome, but we're good. So my 960 luckily kept it. Today, Alan, new news broke 4 hours ago. Somebody left the first comment on my site saying, Paul, a new firmware's out for the 960 Pro, and it seems to fix my dropping issue. That's the wonder of, having a comment system where people can share with you. It's awesome.
Yeah, exactly.
It's such a plus. It's only one data point. It's one person. I haven't confirmed it.
Yeah.
But it gives me a little more confidence that maybe I'm buying one of those when I need 2 terabytes because the Evo is only going to 1 terabyte. And we already talked about my laptop where the 2 terabyte 2.5 inch SATA, that thing overheats a bit. It'll do thermal throttling, which people really don't talk about.
Right.
On a ThinkPad before, on a Dell now, laptops are not great at handling extensive heavy I/O on SSDs.
That's true.
The other little thing
I mean,
that people rarely talk
about. It's a small, very compact form factor. I mean,
Correct.
It's
and I get thermal throttling there a whole lot more than an M.2.
Yeah.
So just pointing that out, people rarely talk about the throttling that goes on there. I've seen the Samsung warn me, your temperature's high. Samsung Magician will come up.
Yeah.
Have you ever seen that? I don't know. I saw it.
It doesn't pop up, if it gets close to the temperature. Yeah.
All right, so we covered all that. Great. Thank you. So we got to the current. Let's close up with, 40 minutes in. Let's go a little bit
So you want to talk about the
peek of the future, right? Oh. So 3D XPoint. So we talked a lot about NAND, and you take a controller that heats up quite a bit on a gumstick form factor, M.2, as it ties together NAND as one lump of storage, a single C drive in Windows, or a nice speedy VMFS in VMware, which, by the way, is usually unsupported. This Samsung consumer stuff we're talking about, you're not going to find on HCLs for VMware.
Oh, sure.
Just point that out.
Of course.
But it works great as a VMFS. You're supposed to buy the enterprise one. So two things.
Not supported, but works. Yeah.
So current technology, enterprise versus consumer, and then a little bit about future. So you said something really interesting on PC Perspective podcast. A couple of times you dropped it in the last 2 months. It's here we are recording in early April 2017.
Yeah.
February, March. You mentioned, by the way, home user, enterprise drives probably not really your friend in a home lab. You might think or gamer. You probably might think you're getting incredible start times in your game, or you're doing great things for your virtualization lab. But unless you have a really good RMA or warranty, whatever, tell us what you said. If you could just summarize.
Not just that, unless you have a really good backup
regimen. Oh, that too?
Because enterprise drives, if they,
this is great.
At least in the case of Intel specifically, I can confirm, they have what's called an assert mode in their firmware. It's actually a mode baked into their firmware. It can basically flip over into this mode where it shows up, I think it shows up as like an 8 gigabyte volume or something that doesn't have anything in it. It's like a debug mode or something. It does this on purpose because if the firmware sees anything odd going on anywhere, Intel literally puts these controllers in like particle accelerators and tries to flip bits to make sure that their firmware will do this when it's supposed to, if just a bit randomly flipped. And so instead of risking corrupting any of your data, a data center Intel SSD at least will just put itself in this mode, and it doesn't come out of this mode. There's no tool. Intel can't send you a thing to get it out of this mode. It's just gone.
Yep.
So you were talking about having an SSD fail before.
Yep.
Imagine a hair trigger on a failure.
And abruptly it stops.
Yeah, and it's just done. And you would think, well, that's kind of crappy. Why would an enterprise drive do that? Because IT pros do not want to troubleshoot intermittent faults.
So U.2, or you got multiple devices, maybe even hot swap. You now have RAIDs of NAND, and you want it to drop. And you want your RAID to just say, Okay,
Yeah.
that one's a little
Yeah.
bit marginal. Intel firmware is programmed to just drop.
Right.
Not what you want for a consumer at home who only has one of them. They're putting a lot of data on.
Exactly. Exactly. And especially if you consider that the mentality of the majority of people, unfortunately, is, you know, a person that might have thought they might have lost data with a hard disk, once they get comfortable with an SSD, they'll get too comfortable with an SSD to the point where they're like, oh, this thing's not going anywhere. This thing's amazing. It's never going to fail because it's not mechanical. And so they're even less likely to back up.
There you go. All right.
You know, and so now this drive, this enterprise drive that they got some deal on or something, you know, their power glitched to their house or something, and the drive didn't like what it saw for a split second. Now it's in assert mode. You know, would have helped the IT pro immensely by just failing immediately and just being done and RMA me, something's wrong, versus, you know, if that same drive had their client firmware, like for, say, a 750 series SSD, it wouldn't have done that. It would still be working. See my point? So it's all down to just firmware and how sensitive it is to, you know, kind of issues like that. So, and you know, I've spoken to other companies, and a lot of them have this sort of a thing. Maybe not the same thing with the same name or whatnot, but yeah, it's an enterprise. You don't want to be troubleshooting intermittent faults. Like, it really sucks to try to do that in any system.
If you work with supercapacitors, the little yellow thingies, or power loss protection that are on the longer NVMe typically.
Yeah.
So today we're talking 22110. Doesn't fit in a lot of ZND motherboard compact cases,
That's
by
true.
the way. Without a Dremel tool or getting a little creative, or PCI riser cards, and there's all sorts of things you can do there with ribbon cables to PCI. You can get creative with, you know, Velcro and ribbon cables, but
you can.
That aside, any comments about power loss protection supercapacitors? For basically the idea here is, well, you lose power abruptly. If you could tell the listener what happens there, you yank the power cord off the system, the motherboard, everything just dies instantly. What is that PLP doing for you? That supercapacitor?
So it all depends on how it's implemented, really. Because some of power loss protection is down to how the firmware does its thing while the drive is operating, and then the other part is actually having some, you know, capacity of power. So that's where your supercapacitors come in. But it's really just down to there are different things being updated within the SSD. A lot of SSDs have you know, a fair amount of DRAM on them. And they're handling like what's called the flash translation layer, which is basically a big lookup table. So if you write to the beginning of your partition on an SSD, the data does not necessarily go to the beginning addresses of the flash. It might put it at the end. It might put it in the middle. It could go anywhere, right? To be able to do wear leveling and write combining and all the different things that SSDs have to do to operate and to level out the wear and, you know, increase the endurance and whatnot, it's not a direct, you know, one-to-one thing. When you write to the beginning, it goes to the beginning. So you need some sort of a lookup table, like a database sitting on the SSD. Best place to put that in RAM. Well, if you just made an update to that table of that file that you just wrote to the SSD, the data may have been written to the flash correctly and finished. However, the table updates may not have been also written to something that will persist when the power goes away. So potentially, if you yanked power right at that moment, and there was no power loss protection, the next time you went to read that file, the SSD would literally read from the wrong location because it had not yet updated the table to point to the new location where it just put that information. Right?
Kind of goes back to those RAID caching controllers we started talking about, where you had power loss protection with a battery.
Yeah.
And weird things happen if you didn't have that battery. So
yeah, that's the exact same kind of thing there.
There you go. Here we are 6 years later, same kind of thing going on.
But in the case of the RAID controllers, it wasn't so much a table that was remapping things that was being updated. That was actually a cache. Like that was
true. It's energizing the cache so it can hold on to it until you replace the drive. Okay.
Yeah, it was like the last, you know, decent RAID controllers have like a gigabyte of RAM on them. So if you were doing a large write, it would go to the RAM first on the controller, which it could go into faster than it could pay out to the disks, depending on how fast the disks are, right? So potentially you would have like up to a gigabyte of data that was in flight that still hadn't been written to the disks. And if you kill power right then yeah, you want, like, when power comes back, you want that RAM to still retain those contents. And what would happen is once the array came back up and the drive spun back up, the RAID controller would go, oh, okay, let me finish writing that stuff that I was trying to write before. So that's a little bit different than power loss protection on the SSD, is to protect from corrupting or just having an incomplete version of the table that's directing you to where the stuff is, right? Like a regular RAID card will not have that kind of a table. It's just a very flat, when you write to the beginning of your array, it writes to the first locations of all of the disks. Like that never changes, right? That's not, you know, that's like a very flat kind of thing. Whereas for an SSD, it can't be a flat kind of thing. Otherwise, you would burn out the first few addresses of all of the NAND. If you were able to just rewrite to all of it continuously like that, that would be really bad, right?
Yeah, no, thank you for that. So actually, that brings me to, well, part of why I ended up in Cincinnati area. So tomorrow I'm working on a vSAN social lab, where NVMware and Intel get together to present a social lab, meaning customers who might use something called vSAN, tying together a bunch of, well, hybrid, could be spinning drives coupled with a caching layer of NAND, right? Or all NAND, all NVMe even in the future, or today, all NVMe. You tie it together with 10 gig and multiple hosts, and you make a RAID with software, right? There's no RAID controller, really. You could be in JBOD mode. You tend to use power loss protection. So the stuff that's on the vSAN compatibility list from VMware has those PLPs we just talked about, the supercapacitors, those yellow things you see on the longer M.2.
Yep.
Inside of U.2, enterprise focused again, typically not really found in a home lab. U.2, what is that? It looks like a tall 2.5-inch SSD you would normally put in your laptop.
It's a little thicker.
A little thicker, right?
Yep.
And if you think about an enterprise where you need to be able to frontly accessible bays, you need to pop them out, right? Hot swap.
Yeah. They make 2Us that have like 24 U.2s in the front of them.
Correct.
Yeah.
Yep. And there's many brands of companies, and they're proliferating, right? So this year, 2017, you'll see even more of that, where it might be M.2 inside, right, Allyn, of this U2 enclosure. It might not be.
I mean, it could be.
But it usually isn't, right? It's some other shaped PCB if you open it up.
Yeah. I mean, they do make adapters. Somebody makes like
That's true.
You know, really low cost, like simple M.2 to, because an M.2 2280 will fit in a U.2.
Okay. All of those are going through PCIe 3x4.
Yep.
Now, you move forward to 3D XPoint. Branded as Optane by Intel, branded as Quantex is by Micron.
Thank you for calling it XPoint and not XPoint.
Good. Thank you for pointing that out.
There's too many people that...
And while we're talking about that, that's capital X, capital P, lowercase everything else.
Yeah, and the X is meant to talk about cross, which is the structure of how the cells are laid out. And there's basically a crisscross pattern of word lines and bit lines. And
there you go. So, and then, by the way, vSAN, lowercase v, uppercase SAN.
Yeah.
Now, XPoint. So fundamentally different than NAND. Everything else we've been talking about for most of the time was NAND. XPoint, well, let me back up just a moment. We talked about NVMe a lot. What did NVMe do? It let you jettison the old SAS and SATA protocol overhead stuff.
Sure.
Those interfaces went away. They were really designed for spinning drives a long time ago in the enterprise. Those acronyms just go away. Now NVMe, you just stick right in a PCI slot or an M.2 slot on the motherboard.
Yep.
All that old SATA and SAS stuff goes away.
Well, cool. SATA and SAS had a lot of overhead associated with, like, there's a bunch of, you know, basically a bunch of routines that the kernel would have to go through and a bunch of hoops it would have to jump to just to conform to SATA or SAS protocol. And it was very expensive for each I.O. Relatively, right? And for hard drives, no big deal because you're only doing 200, 300 IOPS or something like that on a good day, right? Whereas now you have a SATA SSD that can do 90,000 IOPS. Now the performance penalty and how much CPU work per I.O. there is starts to get noticeable.
Think about that in a data center where many VMs are trying to slam SATA or SAS. You got a lot going on with the driver, keeping those little virtual machines busy.
You potentially run into, like, running out of cores on the system as far as you're pegging all the cores trying to access all of the storage.
Okay, so let's talk about that a little. So 3D XPoint, garbage collection, background housekeeping, stuff like my Corsair used to do, a consumer drive, where I would do something kind of cheap in the home lab. I'd say, oh, VMware, when I import this and I'm going to reformat it VMFS instead of NTFS from whatever Windows project was on there, just nuke it. But instead of filling it to 100%, I'd format it in a VMFS at 80%, leave the other 20% doing nothing. Why? Because it was consumer, it wasn't enterprise. So you know how, like, you buy, well, you know this, consumer, 480 would be your capacity, 480 gigabyte. You buy the enterprise version, it's 400. The reason is, well, what I just said.
Over-provisioning.
So I do my cheap, poor man's over-provisioning with consumer SSD that performed really horribly if I accidentally filled it to 100%. And if I had formatted VMFS, I'd have to pull it out, secure erase it with some Windows utility and put it back to VMware. So I got tired of that and finally just said, okay, I'm only going to give 80% to VMFS. Now let's talk about 3D XPoint. Background, a lot of that goes away.
A lot of that goes away.
Can you explain why to the listener, this is a big deal.
For an SSD that has NAND in it, so this is your SATA SSD, this is your NVMe SSD, all of those, right? Anything with NAND flash memory in it. Basically, they have to do a lot of tricks to make this stuff work as quickly as it works right now. Like the page size, so you can only write flash in pages. have to write a page at a time. And the page sizes have gone up over the years. So since you had, you know, SSDs like X25M or whatever that only had like 4 gigabytes on each die or 8 gigabytes on each die, you know, not a lot, right?
Yep.
Now it's getting to the point where you're seeing stuff that's going to be coming out that's like a lot more per die. Actually, sorry, X25M was like 1 or 2 gigabytes per die. It was like on the really low end. Now you're like 4 and 8 and pushing 16 potentially, right?
Yeah, Samsung 960 Pro M.2 fits 2 terabytes these days for that NAND. Yeah, that's weird.
So to get more space on the die, you have to start. There's compromises, right? So the only way you can rewrite flash is to erase a block. Well, the block sizes have increased over the years. So like X25M time, it was probably like block size might have been like half a meg or a meg or something, and the page size might have been 2 kilobytes. Okay, so think about this. You have to, once you've written all of the space on the drive, in order to even change a single sector from that point, since all of it has been written, you can't just rewrite a page, which is 2K. You actually have to erase a block, which is a half a meg or a meg, and then clear a block of it. Now you have this empty block. Now you can write that page that's updated. And then go back and talk about that database I was just talking about and update the entry to point to the new location that you just cleared for that piece of information. Even though you were overwriting something that was in place, it actually had to go somewhere else on the flash. So think of all this musical chairs that has to take place just to do a single random write to this NAND flash memory. Now you fast forward to today, where you end up with like page sizes that are 4K or 8K and block sizes that are pushing like 6 meg, like 8 meg, potentially more, right? So you're now juggling an awful lot more data on the flash. So think about like all of this work that flash has to do in the background just to support you trying to write, you know, save your one word you changed in your text file on your disk. It literally has to move megabytes of information around to update the one character you changed, right? All of that goes away on Crosspoint. Crosspoint is in place byte overwritable. It's actually bit overwritable. In other words, there's no block to erase. There's not even a page to erase. You don't even have to erase the cell first and then rewrite it. You just write to it. Whatever operation takes place in order to write to a bit of Crosspoint is the same if there was a bit there before or there wasn't. It doesn't matter.
You're about to hint about consistency. That's the game changer here.
Yeah, that's the other thing.
You know what's going to happen when you request that write.
Yeah,
whereas before you might have some background garbage collection or whatever, some housekeeping the SSD was doing at the most inopportune time, especially in the enterprise. Your transaction-based bank or whatever, you want your SSD to perform at all times with a certain performance characteristic you can guarantee. Not 1 in 1,000 or 1 in 10,000. It's abysmal. You want it all to be amazing.
Yeah, you want it all to be amazing.
And that's the graphs you've been doing. That remind me, by the way, of Byte magazine 20 years ago where you read science articles. You go through 20, 30 pages of graphs, right? You bring me back there, which is awesome and very valuable. So latency percentile. That brings me to that term that maybe you coined or you've been doing a lot with that.
I kind of learned
the high-level version as we bring this in for a landing?
I learned it by trial and error. We were initially doing like what is actually an I/O percentile. In other words, the kind of thing you would calculate QoS off of for your, if you see an enterprise SSD, it has QoS specs. Like 99% of the IOs are going to be at least, you know, be no longer than this amount of latency, for example. And then they go all the way up to like what's called 3, 4, 5 nines, which is, you know, 5 nines is 99.999%, right? So they're being extremely, extremely critical. In other words, it's just higher and higher degrees of we really care about like all of the IOs being perfect. We realize that not every single one of them can be, because you're going to have a hiccup at some point, right? But the idea is come up with a spec that lets you see what it's doing the majority of the time.
All right.
You know, anyway.
So the way to visualize that is what you've come up with. A lot of work.
Well, the way to visualize that, it actually started not meant for the enterprise testing. It was actually me applying an enterprise testing principle to something to show how client SSDs were performing, because we would have SSDs come out that would actually stutter, but only do so intermittently or every so often. And, you know, we'd end up with just like, this SSD performs great if you run a typical benchmark on it that just tries to see how high the IOPS can get or how high the throughput can get. But you would have inconsistencies that would get lost in the average. right? So if you ran a test for 10 minutes and you publish, okay, here's how fast it went, on average, over 10 minutes. Well, if
things like iometer, if something really weird happened in the middle of that run, you wouldn't see it.
Yeah.
If you average right out.
Pretty much any test, most tests just give you a set of numbers at the end. And, they might give you like a maximum latency or something like that.
They're 10, 20 years old, these tools. The tricks of the trade.
Exactly. So even the tools that give you an average and a maximum, the maximum is bunk anyway, because you might have a product that performs great, like all the time. But if Windows did a context switch during the test, like your maximum latency, you'd have a spike. It's only one data point. It's just what was the maximum I/O. So that's kind of useless, right? So you really need to think about this in terms of percentiles, right? So I took the enterprise methodology kind of thing, ported it over to running client type workloads on client SSDs to be able to point out if a drive is inconsistent. How do I visualize that inconsistency? How do I plot it on some kind of a simple curve that someone can look at and just understand that, say, half of the time this thing is going hard drive speed. The other half of the time it's going SSD speed, for example, right?
Yep.
And that's the thing that I call latency percentile, which is different than I/O percentile. And all I'm doing is I'm taking the same results. I'm just weighing them based on how much time the I/Os took, as opposed to the I/Os themselves being the weighting, right? So instead of if a drive is going fast for 3 seconds and then really slow for half a second, right? You could have 50% of the I/Os fast, 50% of the I/Os slow. The reason it's 50-50 is because the slow ones took longer, but it was doing it for less of the time, right? It could all balance out. But in reality, the drive could have been going hard drive speed that other time if it was going so much slower, right? It's possible to measure something even using the enterprise style where you're looking for, say, 99.9%.
Yep.
If a drive, we actually had one drive that the manufacturer had to go back and fix their firmware before they launched it because it was going very well performing, but then for a 10-second burst out of like every 30 seconds, it would go so slow, it was even slower than hard drive speed.
Yep.
And if you looked at that drive on an enterprise style QoS chart, it actually passed the 3 nines and like the 4 nines because there were so few IOs that were taking so long, they actually escaped the 99.99%. Right? You follow that?
Yeah.
So we had to adapt the enterprise methodology because it didn't totally work for testing client stuff, because in a client machine, if the IOs slow down that slow, you're waiting for every one of those to finish. Like you're trying to launch something. It's not like an enterprise where it's, that just means that this 1% of transactions just went a little slower because there's a bunch of parallel transactions going on, right? Yep. It's not the same on client. Client, every single IO matters, right? So we had to kind of flip all that around and come up with different ways of visualizing that, and that's one of the big things we do in reviews on the site. And then lately we've gotten a little more creative with applying workloads in a way that's more consistent with what actually happens on the consumer system. So in other words, not just doing a test that goes Q depth 4, how fast does it go? We don't do that. We actually apply like a paced IO stream. In other words, say you're downloading something in the background and you're trying to launch games or you're trying to launch Office or whatever. We're actually issuing that like a fixed number of IOs, sort of like a trace playback, but not the same as playing back a recorded trace, because we're doing it in such a way where we can record the data to present the percentile information, right? So it's, normally whenever you see enterprise showing, 3, 4, 5, 9 results or whatever, it's always at a fixed Q depth. It's like, we test this SATA SSD at Q depth 32. This is what the 3 9 and 4 9 performance looks like for this enterprise SSD. Client stuff is never rated that way. They're always just, it's this many IOPS at this Q depth, right? They don't care about consistency in their specifications. And since they don't care about it in a spec, the client side guys, the regular consumer SSD guys, started kind of getting lazy on their QC is the best I could put it, right? So that kind of stuff would get totally overlooked, which is why I had to come up with testing to show it, because there was like huge differences between drive A and drive B.
So let me try to paint a mental picture for people listening to bring this 2 points home. I'm going to talk a little bit about RAID and software, what that means.
Yeah.
And then finally, we'll go back to Optane and the fact that you can have expected results when you ask a drive to do something.
Yep.
And then we'll hint at what happens when you break through the PCI barrier and you go with DIMM slots. So
sure.
that's what we would close it down here. So imagine you have 4 hosts, 4 servers, right, running something like ESXi, and each has a caching tier and a capacity tier. So there's your minimal vSAN. 4 would be a magic number because you can tie it all together and let's call it something like RAID 5.
Sure.
Where you can handle yanking the power cord on one of those hosts and it handles it fine.
Yep.
All right. Now, when it's healthy, it's running along. But what if the vSAN smarts say, hey, vSAN node number 2, ESXi host, please lay down this data. But it's SAS SSD is a little busy with some housekeeping stuff or the controller or whatever.
Or it's a consumer version someone bought that's a stuttery drive.
I'm not ready, and it's RAID 5, so it has to write in multiple places, so it's kind of holding things up. Like, I can't right now, I'm busy doing housekeeping.
Yeah, it's an amplifying effect. If you have inconsistent SSDs in a RAID, it will multiply across the RAID.
So the client workload, the person running a VM on that storage might feel it momentarily.
If you had 4 SSDs, or in this case 4 different nodes,
I tried to simplify the storage. Yeah, caching layer and capacity layer, essentially 4 storage things.
But say you had a device that kind of hiccuped, like every 10 seconds it hiccuped for like a second, just hypothetically, right?
Yep.
Well, now you put 4 of them. The thing is operating in parallel. It's a RAID.
Yep.
So now what are your, think of your statistics there. You have 4 things that are pausing for a second out of every 10. They're not all going to be pausing at the same time either. So now basically 4 seconds out of every 10, almost half the time, you're stalled, right? Yep. So that's how that works out.
Similar concept with RAID 6, less risk because now you can handle 2 hosts going offline.
Yeah,
but either way, everything you just said still applies.
It all still applies. Same exact way. Yeah.
Looking to the future, right? I want to end this with PC perspective. Week in and week out, you talk about amazing storage topics like this, and you nerd out. You get into the weeds, which is why I listen, right?
Yeah.
So this is meant to just be a teaser for what you cover every week, which is phenomenally valuable. And the teaser's for that future where, okay, you get away with the PCI bus, you go to 3D XPoint, which for now lives in the world of the product that was released 2 weeks ago, was the Intel.
Well, there's 2 of them, right? There's Optane memory. That's an M.2 SSD that goes into, it's meant for client. It's meant to be like a caching layer.
Consumer under $100 caching layer. Let's focus on the exciting one in the PCI slot for enterprise would be.
That's the P4800X.
There you go. That weird model name. And it's game changer, but still PCIe 3.
Yep. It's 375 gigabytes worth of that XPoint memory.
It'll keep your PCI bus pretty busy.
I mean, it will if you can throw stuff at it quick enough to keep it busy. Yeah.
Yep. So
that's the challenge,
and that's this year's technology. Emerging now. Right? Yeah. And VMware was there day and date announcing vSAN compatibility for that should be showing up in the VMware vSAN compatibility list. Okay, fine.
Yep.
Now what happens when you take away PCI 3.0? That's the teaser. It's only early April. I can't talk about new vSAN much. You can't talk about Optane too much quite yet.
Yeah.
But the teaser is. What happens when you lay all this down to the motherboard, right?
Well, then it's going to get even better. I mean, you have to think of your typical NAND SSD, even like an enterprise part, even like a high-end part, your latencies are still in the range on the order of like 100 microseconds. Like, so you ask for a piece of information, you get it back around 100 microseconds later, right? RAM runs in like 100 nanoseconds.
Yep.
That's what you're looking at for direct RAM. So now you have like 1,000x difference there between those two, as it is right now. So there's a huge gap between NAND and RAM, right? XPoint stuff that's on an NVMe, in other words, it has to go through its own controller and it has to go over PCI, so you're adding latencies. Because as silly as it sounds, PCIe 3.0 is actually a huge bottleneck for a bunch of XPoint memory sitting on a card, right? But even despite that, you can still knock like 10 or 100x off of the latencies. Depending.
And it meant nothing, by the way, that my 6-year-old Sandy Bridge could do PCI 3.0. I never used it with my LSI controller.
Right.
But in today's world, we're now talking about it starting to mean something.
Yeah. So XPoint on a card, which is the first thing that anybody's going to be able to get their hands on, because the DIMM style XPoint is still going to take some time, probably like another year, another 2 years or something.
Remind the listener of the length, by 4, by 12, by 16.
So we're talking just like a piece. So the P4800X is just a.
How many lanes?
It's 4 lanes.
Thank you. Just to
remind. It's actually, I'm pretty sure it's going to be, just based on looking at the specs, it looks like it's more limited by just the controller can only move the data so fast. And like, this is the first generation that can talk to XPoint, right? We know XPoint can, talk as far as throughput goes at RAM levels. However, the controller, is going to be kind of a limit on the first generation of a XPoint RAID, not RAID, XPoint, NVMe talking device. Right?
So even though we're taking up a PCI slot, It's really the same form. M2 is just a different form factor. That same PCIe 3 by 4 lanes.
Yeah.
In theory, a cross-point.
The card looks almost identical to a P3700, which is
correct. We just don't have affordable Optane that's an M.2 gumstick form factor yet.
Sure. And I don't think they would want to put, like, you got to realize the performance you would get out of that part, like even the 2 cross-point dies that Intel puts on the Optane memory part, which is the M.2 part,
Yep.
the performance is so high that it's actually going to draw close to the power of like your typical gigabyte or 1 terabyte or 2 terabyte M.2 NAND SSD.
There you go.
The performance is so much higher and the latency is so much lower that it's consuming power just because the throughput numbers are so high. Like, so it's, even though it's only 2 dies of it that are operating, it's that they're operating so much faster.
All right.
That the power consumption is almost equivalent.
How many watts are we talking for that?
Like, I think it's like 4 or 5 watts or something.
Yeah, okay.
But you know, most of them, like, I think the most you want to draw from M.2 is like 6 watts before you really need to start needing heat sinks and stuff like that. Right.
Okay. So what happens when you go in a DIMM slot then?
So,
or something like a DIMM slot.
Yeah. So for DIMM slots, so again, you have this 1000x latency kind of, you know, valley between NAND and RAM, right? So
say that again. It's a big number.
It's 1000x. Yeah. So you're literally 100 micro to 100 nano. That's 1000x, right? So you can get.
And where's 3 crosspoint fit in that?
The rating that was leaked was on the order of 10 microseconds. So you're going from 100 microseconds to 10 microseconds, and this is for the part that's crosspoint on a card.
Correct.
Talking over PCI. So you're already knocked off 10x.
Nice, but now you're going much further, getting it on the motherboard.
Yeah, but if you put it on a DIMM slot, now you're removing a lot of the things in the way, so to speak, right? First of all, your bandwidth. You have an awful lot more bus lines going in parallel there because it's going to use the same kind of communication that you would use to a DIMM. It's literally the same protocol there, the same, you know, addressing and whatnot that goes across. The only difference is now you're just going to have to wait on the crosspoint die to do its operation, which is probably on the order of like 1 microsecond or lower. So now you're basically 1 microsecond is the point where now you're only 10x away from RAM speed, which actually jives with what Intel and Micron initially talked about when Crosspoint was initially announced, and they were saying, hey, this is, you know, it's only 1/10 the speed or 1/10 the latency of RAM, but so much better latency than NAND flash memory. That's what they were talking about, was when they can get to the point of nothing else being in the way of talking to it, right? So there have been a couple articles that came out recently, and like actually on and off for the whole like past year or two, that have, like, every once in a while someone will say, oh, they said it was going to be this much better, but this product that they just announced is not as good as what they said it was going to do. Well, initially they were talking about if there was nothing in the way of communicating with it. So most of the challenge here is this stuff is so much faster as a non-volatile storage thing, something that stores bits with the computer off. Like, computer infrastructure is not all prepared for it yet.
Yep.
You see what I mean? Like, there's, you know, NVMe is actually sort of a bottleneck for a cross-point on an NVMe device. Even though NVMe is so much more efficient compared to the protocols used for SATA and SAS, even though you reduced it to like 1/10 or 1/50th of the CPU overhead, suddenly you have a thing going so much faster that the CPU overhead is now an issue again, because the thing can go, you know, 10 times, 50 times the performance of the previous NAND-based part, right?
Gotcha.
So you're basically just, you shifted the bottleneck to one thing again, to the NAND flash, but then when you replace the NAND flash with Crosspoint, you shift the bottleneck potentially to the NVMe protocol again, and how much CPU overhead there is even for that.
So let's close on that thought, right? The next year gets even more exciting. Is we learn more about Optane, and then we think more about how do you lay it down on the motherboard. It will change fundamentally the way motherboards in the enterprise are laid out, where it tends to come at the high end and the price point, right?
Yeah.
Consumer will benefit eventually. At some point, we'll reach something affordable, but for now, we're nowhere near capacities of Optane. So shopping today, it's not like holding off for a few weeks or months is going to help you. Waiting for a motherboard that's going to somehow magically handle a 1 or 2 terabyte Samsung 960 predecessor follow-on.
Yeah, sure. But I will say that if you go by Intel's track record, so there was a, you know, what was it? SSD, the data center SATA SSD that was like an S3500. So they had like a data center SATA SSD part that came out, and then that was followed up like about a year later, or like 3/4 of a year later, by the SSD 730, which was a consumer version.
Okay.
like kind of a power user consumer version of their enterprise part.
So it didn't take very long.
Didn't take very long. It was the same flash. It was just different firmware on the controller, basically. If you opened it up, it was the same drive inside. You looked at it, it was you could hold them next to each other and you couldn't tell the difference.
So the mid-March enterprise-y Optane Intel just announced, we're hoping for a consumer-tuned one that doesn't abruptly turn off.
Yeah, could potentially come out. It's going to be expensive. It's going to be very expensive.
Yep.
But it's probably going to be cost per gig on the order of what like the 730 came out at, or maybe a little more than that. Think about it, that was years back when you had SSDs that were still multiple dollars per gigabyte.
Yep. Now, capacity 400 gig or something is where we're starting to see Intel start with all this. I should point that out. We're nowhere near a terabyte yet.
Yeah,
the price was up towards...
It's going to be, like, I think their enterprise, the P4800X is like 375 gig is like the first one they're going to launch. But they're going to go all the way up to, I think...
Consumer might be 400 then, right? Or a little bit, whatever.
Well, no, it might actually be lower.
Oh, okay.
Because they might actually, like, you know, give you a little bit... It's not over-provisioning. You can't call it that, really, for this, because it's not...
Oops,
it's really,
I just fell into the trap. Totally different.
It doesn't work that way. It's,
exactly. Oops.
It's more like there's just some spare area. It's like, because eventually you could have, you know, some cells burn out over time. It's a thing that's not perfect. Like every bit is not going to be perfect. So it's
you're more thinking about RMA warranty, whatever. So you might make it lower capacity, the other direction.
Yeah, it might be a little bit lower capacity. It might be like a 350 or something. But again, we got to see the actual enterprise part come out first and start shipping in volume. And then you can start your counter on maybe it might be like 3/4 of a year to a year if you go by what they've done in the past. You know, because it was S3500, 730 series. Then it was P3700. And then another like 7, 8, 9 months later, 750 series, right? So it's kind of like a track record. So it's only a, you know, Intel did say at their event and allowed us to repeat that there will be a client SSD full of Optane coming. Like you will get one. They don't even know when. Like they haven't decided when yet. So,
all right. Well, thank you. So closing this out, for people listening, if you haven't heard Allyn before, how should they follow you? Both the website and you personally, since you tend to focus on storage terms.
It is PC Perspective. That's pcper.com for short.
And Twitter.
We're doing podcasts actually tonight, in fact.
Yes, live on Wednesdays.
Yeah, live Wednesday nights.
Fun to tune in. Why? Because if you...
Pre-show and the post-show.
That's fun too. I've listened to the live one as a Patreon, right? As a patron, subscriber. You get the perk of the pre-show and post-show, which would be pretty funny. Not to mention what you do on the air is funny. But also, well, you change your pledge while on the air, and Ryan and others give the honor of reading it out loud. It's hilarious. It's fun.
It doesn't matter what you put for your name.
He reads
in the pledge. He reads it. Yeah.
So, Allyn, thank you for this opportunity. So, again, for your tweets that happen to be about storage, you do that under your own?
Yeah, just twitter.com/Malventano, which is a mouthful. And instead of spelling it here, I'll just say, go to PCPer and look me up.
And for me, at Paul Barron. So, thank you so much for this opportunity. Thanks to Ryan for this chance to record this here with a real microphone. It's just an honor to finally meet you. And man, that time went fast. We flew through that. Hopefully
now you know how the podcast goes.
No, it really was a joy. So thank you again for doing this.
All right. Thanks, man.
Just a brief backstory to paint a picture of how this informal, unscripted recording came to be from two early adopter, bleeding edge kind of guys. I'm Paul Barron of TinkerTry.com. And I've been to roughly 35 to 50 United States doing consulting. I'd actually been to Cincinnati's airport before, which is actually at the northern edge of Kentucky. But this time, I'd been all over Ohio to meet with customers and to help out at Cincinnati's VMware vSAN Social Lab, a guided hands-on lab sponsored by both VMware and Intel. You see, all-flash vSAN is when you aggregate individual disks into a pool of fast storage using 10 gig or beyond networking. And this recording is all about the technical underpinnings that make all-flash vSANs possible. So while near Kentucky, I reached out to a PC performance enthusiast and self-made storage expert, an ex-Navy guy named Allyn Malventano. He's living in Florence, Kentucky, just a few miles south of Cincinnati, a town where the huge water tower seen from the highway as I drove in said, "Florence, y'all," which gave me quite a chuckle. This is also the hometown of PC Perspective founder Ryan Shrout. and his recording studio, where the weekly PC Perspective podcast and videos are produced, that I've so enjoyed for so many years. Allyn has done so much in his career before becoming the storage editor of PC Perspective, and I've referenced his work hundreds of times these past 6 years of writing at TinkerTry, because his work is incredibly technical and in-depth, going into all aspects of storage. And his Audible segment with video on the weekly podcast brings his hardware tests to life, supplementing the learning so well. This audio was recorded Wednesday, April 6, 2017, just before Allyn went on the air at pcper.com/live for the weekly 10 p.m. Eastern recording. If you enjoyed what you just heard, this storage conversation, please also consider subscribing to the YouTube channels for PC Perspective and or TinkerTry. And you can follow Allyn at Malventano, Malventano, and me, Paul Braren, at Paul Braren, Paulbraren. Thank you for listening.